All right, Hacksters, you asked for more projects, so that's exactly what you're getting. I'm here in Portland, the home of OSH Park, for the Teardown Conference. And so I've been working on this PCB project that I called Charmware. Finally came up with a name for it, and it's basically a set of modular PCBs based on that help you build like necklaces and like other flowy, sinuous circuits, because that's how I picture them in my head. When I draw circuit diagrams, they're not like rigid squares and stuff. They're these sort of flowing things that really show how things how the electrons move through, I guess, space. I like this idea because it can be very 3D as well. Anyway, so I've been working on this PCB project, and I got a couple friends to help me last week because I was still really intimidated by the process of making my own PCBs. So my friend Turner Kirk was introduced to me by my friend Moldover, and has done a bunch of PCB stuff in the past and helped me design these. And I've just ordered them for the first time. I ordered them to the hotel so that I'd be able to get them in time for teardown, and ideally, use them to make something for Maker Faire. So I'm really stoked to open these up. This is the first time I will ever have laid eyes on a PCB that I designed, which is crazy. We're gonna look at the design stuff too in a minute. Oh my god, look at them! Oh, they're in little sticks of 3, like all OSH Park PCBs. These you ordered them in multiples of 3 because that's how they're laid out on the panels for creation, with a bunch of other PCBs. So wow, this is so cool. So they say PC Beads V1 because that was my original name for these. It took me a while to come up with what I thought would be a good moniker for these. Yeah, there's a lot that goes into naming, but PC Beads is pretty descriptive if you know what PCBs are, but people might not know. So I went with Charmware because they're charms, like, beads, charms, but also there's this kind of magic idea going on as well. Oh, and I'm already seeing some ways that I could improve this. But yeah, so I've got a project for this up on Hackster. Wow, this is so cool. And I want this to be a collaborative project, so I'm gonna keep working on this, but I would love it if other people design more of these, because the idea is that it's modular. Really, anyone can contribute and make your own things. So a few that I have planned coming up next are like transistors, and like little chips, like 555 timers, or like AT-tiny chips, the sort of basic ones that you see. I'm just gonna snap them apart. Ooh, that's so cool! Then of course I'm gonna cut off these little, snap off these little bits. Yeah, so I took a very aesthetic approach to designing these. Let me grab one for you. This is the first one. It's called the Star. And basically it can hold resistors, reed switches, or LEDs. I wanted these to be as flat as possible, so I designed them to be able to take a 1206 surface mount package, and that's basically a small flat object, but it's big enough that you can still solder it by hand, because I don't want you to need to do surface mount soldering in order to put this thing together when you order the components. And I think that a 1206 package comes right in that really easily solderable by hand way, but it also is very low profile because it's a surface mount piece. Then you also have this place across, which allows you to put a resistor in, and then across here, I'll tell you a bit about the system in a minute, but to start with, you can put like a reed switch across there, which is one thing that I want to do for a switch. If you're creating a necklace, you can use magnetic beads and then stick that to one of the PCBs, a reed switch, so that it turns your necklace on or off without any real moving parts or buttons or switches or anything. And I think that's a really organic way to go about it. I also chose to make two ground planes. Well, one's a ground plane and one's a voltage plane. So it just goes across like that. And I thought that added an aesthetic element as well as being functional. It's a little bit unusual, but this is all about play and fun. I took a lot of inspiration from the approach of Boldport, Star Dreamer, who talks a lot about how you can design something so that it's maximally functional, but you can also design something so that it works pretty well and also is really gorgeous, and you get to sort of indulge your aesthetic side as well. So I've also ordered some of these. You see these are pretty thick still. I've also ordered some in half height. So this is the star. Let's take a look at it on OSH Park too, actually. um, so basically, I started out in Eagle with Turner, and this is a look at what this star looks like in Eagle. It's all shown from one side. You can't flip this around, which was really weird for me as someone coming from 3D modeling. Like you do all the imposition of layers from the top. And so that's why there's only two triangles here that are dividing the planes, because that's actually two superimposed triangles in each spot for the top and the bottom copper pores. And then the silk screen, which is on the bottom layer, all the components and stuff, there's like a resistor laid out here and an SMD LED here. All of that stuff is on the top, and then the silk screen is on the bottom. And one thing that Turner Kirk did that was really cool was that he actually he made some custom devices in here, components, so that they wouldn't have any silk screening on, because that was something that I wanted from an aesthetic standpoint. And I later modified it so that this one is surface mount instead of being another through-hole one, because the LEDs really want to sit flat against the surface. And I don't yet know how to create my own components, so it's still got that silk screen in the middle, but that's pretty small. And yeah, so let's take a look at more of the ways of like putting this stuff together, right? So in order to find the proper size of surface mount package, I looked up the dimensions, all of these, and I found that this is a really useful page. It's just, they just mention resistors, but for just knowing what surface mount sizes are, this is really useful, because a 1206 package LED is the same as a 1206 package resistor, pretty much, in terms of like gross physical dimensions, and I should be able to solder both to the same set of pads. So they have some pretty cool visualizations there, and this is here at resistorguide.com, and then resistor sizes and packages, SMD resistor sizes. Super useful. When it came to naming, I had a few ideas. I started out just saying PC beads, as I said, because that's like really easy to understand if you're coming from the sort of hardware standpoint. But I'd like for this to be more widely understandable. Like if I were just coming to making, and I saw something called PC beads, I'd be like, oh, I bet that requires some sort of specialized knowledge or ability, or like I'll have to know how to surface mount solder or whatever, or like if I even knew what a PCB was. I know people who have been making for years and don't know what a PCB is, and that's totally cool. So I wanted to make sure that this was a little bit more accessible, and yeah, so I feel like Charmware sort of gets the point across, but doesn't require that. And then I also did a little bit of research just to make sure that there's no namespace collision. Googled around all the ideas that I had for names. I was like, cyber charms? I don't know. And it turns out that like on Etsy, there's like a keyword that sort of, you can search for that. But I didn't find anything that actually sort of infringes on there. I mean, there's always some sort of like slight collisions with like, article names and stuff, and there's always going to be a little bit, but there's not much in terms of collision here. And then if I look for Charmware, there's just totally nothing, which is great. Wait, there's one thing. What? Okay, when I looked this up before, those first two links were not there, so I'm gonna check that out. But it looks like one of them at least has not been. These are both like free sites, and it looks like this one at least has not been updated in a while. So I'm gonna guess that like they're probably not doing the same thing, and that's close enough. But let's see, just in case. Yeah. So I feel like this one is not gonna be much of a problem. And then what about this one? Da 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 da. Yep. Okay. So yeah, naming, like, the internet grows larger every day. There's less and less space for new names for things, but I think this one is very descriptive, very approachable, and also doesn't have a lot going on in terms of already claimed real estate. So, ooh, yeah. Let's keep looking at these new ones because I'm really excited. So that, I showed you the star, right? The first set of these, I want to make a number of different designs. So these ones are all named after celestial bodies. And I'm especially excited about the Dyson. So this is a coin cell battery holder. And it's called the Dyson because there's this concept in science fiction of the Dyson sphere, and it's named after Freeman Dyson, who like popularized the concept in the 60s, but it was originally created by Olaf Stapledon in the 30s. And the concept is that of basically a civilization being able to place solar energy capture devices around their native star so that they can power their technology and make their world, their existence better. And so I thought that was a really cool sort of astronomical equivalent for a coin cell battery. So this is the Dyson. Yeah, super nerdy. Woo. This is so cool. Let me see if the other ones are in here as well. Oh yeah, whoa. Well, there's at least one more. This is a nebula. So I figured that with wearable LEDs, you're gonna have a really bright LED on here, right? And you don't want it to blind people. Like diffusion is always a huge part of wearable tech, and specifically with blinky lights. So I made these little diffuser boards, and actually this might not work, but maybe it will, who knows? Huh. So this has almost no copper on it, so it's gonna be translucent. And I looked at some of my OSH Park boards that I have, and the vias, which connect the top and bottom layers with very small holes, had teeny tiny holes in them. This one does not. I'm guessing like it just has to do with the size of the via. And what I designed was a whole sort of bunch of little holes that would let a little bit of light come through. And you can kind of see that in the texture on here. Ooh! Dropping stuff all over the place. But the holes, unfortunately, do not go through. And I sort of clustered them toward the middle and then diffused toward the outer area. This is called the nebula cluster. Nebula, of course, diffusing, diffusing light. I also have another envelope here, actually. So let's see. I ordered a lot of these, so... oh, I see. It's just another... Huh. Envelope number 2. Okay, let's see. Do we have any about nebula? Oh yeah, here we go. And then this one is the nebula hole, which also does not have really obvious holes, but that's fine. And this one I played around with removing the solder mask from part of it, and also clustering the vias over to one side, and so that like it would be some kind of different diffusing effect. So this one, you've got most of the vias off to one side, to the right there, and then also this sort of area without solder mask on the back. And these ones I just made by modifying Turner's PCB designs. I'm far enough that I can modify stuff in Eagle. So actually another part of the motivation here is that I will have some really simple PCB designs that people can modify to create whatever they want. So if you don't have a lot of experience, you go into Eagle, right? And there is an example project in there, and it's like an entire Arduino board, and I'm like, what? How do I work with this? And I really wanted to just have something that I could play around with that's kind of safe, There's like, you know, two big planes and you can place stuff between them however you want. That's one of the things that really excites me about this, is that like the hardware assembly is not difficult. The PCB design is going to be approachable. Um, and yeah, it's just going to be aesthetically pleasing. And the way that you assemble them also into a necklace is pretty easy. I feel like I can actually reduce the size of these side holes, because what's going on here is that I am pretty proficient with hemp knotting, creating hemp necklaces, and I used to do that a ton when I was like a young teen. I guess we call them tweens now, whatever. And you can knot hemp necklaces around beads and things. That's like a big part of the aesthetic, like cowrie shells, beads, etc. And you can kind of do that with these. And I think we can actually go smaller because these holes are designed with strain relief in mind. You should ideally be able to put some twine through, but also you can put, you weave your wire through this hole and then solder it to this hole, this through hole, so that you get this strain relief effect. That's very important in any kind of wearable tech. You don't want it to like pull, you don't want those solder joints to be under constant stress from being flexed and moved in different directions and pulled on and stuff. I want this to really be durable. And so, you know, when it comes to making it watertight, you know, that's another question because you've got a coin cell and stuff. But, you know, for one of these, you could put nail polish or clear glue or whatever, or E6000 over it, and it'd be fine. But then for strain relief, yeah, like an E6000 or hot glue sealer will help hold stuff in place, but also it's important, I think, to have this sort of weaving effect that really helps with holding stuff in place and keeping it from getting yanked on. Yeah, so I've got these, I've got four right now. I've got the nebula, two kinds of nebula, one kind of star, and obviously that's just because it holds an LED, but I might go for a different name for that because functionally, yeah, I don't know. And then the Dyson, which is the coin cell battery holder, and there's going to be more coming up soon. Finally, there was one other thing I wanted to share. What was it? Oh, let's have a look. Well, anyway, for now, there's a Hackster project up called Charmware that you can follow. Here we go. It's obviously a work in progress. It's just got a little bit of information. And I put this introductory video up there, and yeah, Charmware. And then also there's going to be a link to GitHub so that you can find the board files. And I don't have that made yet, but it's going to exist. And you'll be able to follow it from the Hackster page. Not only that, but you'll be able to find the open source designs on OSH Park. And I'm going to start sharing those. I have them in my personal account, but I think that there's like a special step that I need to do in order to make those accessible so that anyone can order them. I sort of assumed that these first prototypes, again, I haven't opened them or looked at them at all until the start of this video, so I haven't actually shared any of this yet, just in case there were like terrible problems. And I probably won't share the nebula ones yet because those need some tweaking still. Or maybe I will and someone else can do some tweaking. I don't know, it's up to you. And yeah, so those are going to be publicly moddable. I remembered what the other thing I wanted to say was. So I have this star, right? And I have these nebulae, and they are sort of meant to be stacked, right? You would sort of solder the LED onto here, and then you would put this over it, basically, so that, you know, and then you'd solder the wires to the inside, so that you'd have this sort of stacked sandwich of PCB. Now, that only works aesthetically if it's a little bit thinner. I mean, actually, this is kind of cool. I like the chunky look. That's kind of cool. But what I would like is to have it a little bit thinner, and you can totally do that with OSH Park. So let's take a look at their site and their documentation. So there are a number of different fabrication services. I should have brought an example along, but you can get half-height PCBs. With your two-layer boards, you can have 2-ounce 0.8 millimeter boards, and that basically means that there's twice as much copper and only half of the thickness of the central FR4 substrate, which is like a fiberglass, the middle of the board that the copper is laid on top of. So that means it stands at half the thickness, and I've already actually ordered some, in this half thickness size. And I don't think they will be back to me in time for Maker Faire, partly because I'm ordering them to San Francisco, not to here, because I won't be here anymore. And also partly because they're the same price, which is awesome, as regular PCBs, but they take longer, and that's because there's less demand right now. So the more people who order half-height boards, the faster we'll all get them, which is super cool, because those panels don't fill up as fast. All of the PCBs that OSH Park produces are produced in large panels that are created all at one time. And so they're like, you'll get these notifications in your email about when it's like assigned to a panel, when it's fabricated, and when it's shipped and stuff. So that means that in order for me to place an order of like, 6 of these, I have to wait for enough people to order enough PCBs to fill up a panel, and that can take much longer. These regular height ones fill up apparently every day, which is not surprising. They've got a huge demand. But for the half-height ones, yeah, I'm gonna have to wait a little longer. But I can't wait to get like some really thin sandwiches. That's gonna be really cool. And I kind of want to not have exposed copper on these ones with the vias. I'm gonna make the vias a bit bigger so that they don't, short out when I do this sandwich. But that's the general idea. Let me see if there's anything I missed. Nope, looks pretty good. Again, this is what it looks like in Eagle. It's super weird for me that this now exists like in my hands, and it's really exciting. So I hope you check out, follow the Charmware project. I would love to hear if anyone has ideas for boards that they would like to contribute to the project. I think that there's a pretty solid aesthetic already established, and I would like to get some example boards out there, some example designs into the wild so that people can start from those and then modify it to do what they want. I want to make a smaller coin cell holder. I mean, this is pretty hefty, right? It could be a central pendant, but it's pretty big. And I hope to have an example demo video for you soon of actually soldering these together, because I've got a bunch of the parts ordered. So this should be a cool, fun project for here at Teardown. All I have to do is find a soldering iron, and we'll have a video up for that of you soon. Of that for you soon. All right. Thanks for watching. I hope you enjoyed the project, and I'm going to be sharing more of this in days to come. Have a great rest of your Friday, and we'll see you soon.